Hello. Well, I think I'm online. Let me let's wait for a while so everybody could connect to the stream. And once we have a decent audience, then we'll get started with the stream. Hopefully, in a few minutes, that's going to happen. Um, so I have also introduced this camera in this video. Just to have just for you guys to have a look on the hardware I'm having. So this is the previous project that I built um, using. Um, oh, my camera turned off. So I think there's some issue going on with my camera. Anyways, so this is the hardware that I built for the LED toggle, and here you go with the power module, the controller, and the LED. So um, let's wait for a while. Yeah, so Mustaqim, Assalamu alaikum, sir. Walaikum salam, Mustaqim. Engineer Manib, yeah, my mic is working, but I intentionally turned it off because um, so today it's a real chaos in my home, and that's because we have some guests around, so um, you have to bear with me. Okay, great. The volume is okay. Um, we still don't have the audience which I consider as worth doing a stream. I don't think we got it yet. At least it should be around 1/10 of the class we are having. Okay, now we are gaining some audience. MBU, I don't know what your name is, but Walaikum Assalam. Can you type your name, MBU? I don't know if that's an acronym to something, but or it's something else. I have no idea about um, what your name is. You have to type it if you can. Obviously, it's not something that's mandatory. It's just out of the box. I'm saying this. Muhammad Burhanuddin. Oh, wow. That's a cool name. Uh, I never considered it to be, Muhammad Burhanuddin. Okay, that's great. So the short form is obviously it's MBU. Okay. I think we should get started. Still, the audience watching now is pretty low. I don't think it's good enough. You should ask your classmates to join. I've already waited around 10 minutes, and it's already getting so late. I don't know how we're going to finish all of this. So the main thing is that people are waiting so that when the live stream is over, they get to download this stream and they get to um, watch it afterwards. But it encourages me if you're watching right now, if you're watching the live stream as it is, it's a live stream. It has to be watched, live. Um, it's up to you if but obviously it's more ethical to watch this live stream while it's live. Anyhow, I think it's better to get started now. We shouldn't wait for all of the classmates. I don't think they're serious. I think they are just fooling around. Sir, how we can make a calculator in my controller? Next video for calculator, please. Okay. Well, the issue um, it's pretty hard to pronounce your name. I am calling you Hassan Khan. Okay. Um, I don't know what it's called. So I'm calling you by your second name, Hassan Khan. It's very you know it's not an easy project to make. So I would suggest you to just get hold of whatever you can right now, and forget about making a calculator, because making a calculator is it's much easier when you have everything on hand, when you get to understand the keypad operations, the how a keypad work, how push button works, and how other stuff works on the hardware level. Then it's pretty much easy for you to make a calculator, or even you can make a banking application. You can make it in ATM. Back in the day when we were working on microcontroller, we used to make different stuff. One of my fellows, they worked on I think they had a GSM and they made a mobile phone. not a smart one, but it was having multiple functions. It was having games. It was having the call and SMS function, which is the only function you need a mobile phone for. Yeah, obviously you have to have knowledge about the keypad and other stuff. So unless you don't have some knowledge about the keypad and how to make a push button operational, or even a screen operational for using the 4-bit method, I don't think it's a wise decision to get started right away from with the usage of calculator. However, I'll tell you how you can make a calculator using the serial port. I hope I've gone through the serial port, which is the UART port, and the controller which we are using 89C51 is having one serial port, one UART port, and it's having around with the baud rate which you will be using is around 9600, and we'll be receiving all of the data, all of the commands through that serial port, and calculating everything inside this controller, and then we'll be sending it to to the screen attached or to the UART panel. Okay, let's get started and get in the detail. There's a lot right now to talk about, but let's get started with the video, as it's already getting so late. Um, as you know, I have my hardware laying around. I'll first of all I'll show you what I've got over here is it's a LED blink circuit, in which it's an LED blink circuit which I built in my previous video, and when I turn it on and when I reset it, so right now it's not resetted, so that's why a reset an automatic reset the mechanism for automatic reset is necessary. That's because the when I turned on the power supply of the microcontroller, and there was no auto reset circuit involved, because right now it's on board and it's breadboard, and that's why it's not having the onboard reset automatic reset control. So that's why the LED is turned on, and it's turned on constantly. So that's the reason why we need automatic control. So to reset your controller, you have to connect the reset wire to positive, and then you have to ground it. I'll do that for you guys. Let me hit reset and then ground. So right now the controller is resetted, and I hope you guys have studied about edge controllers. So sorry, the edge clocks. So there are multiple clocks. Some are level triggered, and some are the edge triggered clocks. So the reset button in your controller. By the way, I'm powering it up using my power bank, so that's why it's turned off after a while. Back to the topic. So what I was saying, I forgot it. Okay. Well, I forgot what I was saying. I'll just get back to the chat. Sir, what will you suggest a project that can be helpful for us to understand microcontroller? You'll get to work on different projects when you get involved in your labs. Um, well, uh, we'll see in detail what you can do, because right now I think I've only went through the LED on off and uh, push button, and I have gone through the LCD, and hopefully in this week we'll be studying more more about 7 segments and keypad. So hopefully when that's done, then you'll get to understand, you'll have an overview about everything. Even Hassan Khan, the thing which you're talking about, the calculator, if you want to make use of a keypad, then obviously you can make use of that keypad once you have an idea how it's how we can make it work. So let's get back to the business. First of all, obviously we have to create a project, and you guys can follow me if if you're doing the same thing as me. Let me write LCD. Let me see if you can see it. Oh, my bad, my bad. Let me turn off this, and I have to include another window capture. I hope I can do it. Microvision. This. Yeah. Okay. So here we go with the addition of the files. Let me include this thing over here. Okay. So let me rename this project as Hello World LCD. Hello World LCD. Okay. And now I am going to select the controller, which is 89C51 in my case, and I'll hit OK. And yes, I want that. Right. Okay. Right now, what I want is to create an ASM file, and let's go and create an ASM file. LCD program. I hope that's visible. Yeah, it's visible, obviously. Okay. Well, now what I have to do is, after creating this thing, I have to first of all go over here and select the frequency, which is 11.0592, and also select the hex file. I hope that's visible. Oh, great, that's visible too. Okay. Um, right now, I think that's all for the project. Let me open the book first, and hopefully we can find the all of the data we need for now. Let me open the page. So what you'll do now is, let me first of all, before going into the detail, let me open the book. Let me open book. Okay. Who's this Bakhti Rahman? Bakhti Rahman, walaikum assalam. Imran Arif, walaikum assalam. I wasn't expecting Bakhti Rahman to, join up the stream. Welcome, Bakhti Rahman. Welcome. So nice to see you. Okay. Well, guys, let's get back to business. Bakhti Rahman had me distracted from all of the stuff I was doing. Okay. Bakhti Rahman, you should, yeah, you should keep your comments to yourself for now. Let me get started with the program, because uh, we're getting far away from the project. We are getting stranded. So let's get right back into the project. Okay. Let's open the book and let's see the course content. When I go over here and at chapter number 12, you can see, and on page number 111, all of the the programs for the LCD are already given. Oh, it's not 111, it's 333. Such a unique name. Okay. So at this page, I hope it's visible. I hope it's visible now. Yeah, it's visible. Okay. Bakhtar Iman, you shouldn't be deleting your messages. I've already seen it, and everybody has seen it already. So you don't have to delete it afterwards. Okay, yeah. Pasha Basir. I don't know who that is. Pasha Basir. That's a new one. Okay. Well, so over here, what you can see here is all of the connections for the LCD. And when you go to the next page, you can see the pinout, and there is the hex table for the LCD. You know, the what we call the command the all of the commands are mentioned over here in this table, and the details to that those commands are also mentioned over here. So what you have to do is, first of all, whenever you want to get started with the LCD, when you get your hands on a certain LCD, let me grab an LCD, a different LCD. The LCD which I am having is this one. I'm having a couple of LCDs. Let me turn on the camera so you can see it now. Okay, so it's I hope it's visible. So the LCD which you're going to use is this one, this 16 cross 2 LCD. The LCD which I have with me is like I have a lot of LCDs, so I'm gonna place this new LCD just to for you to have a look. This is 20 cross 4 LCD, and you can look at the size difference as well. I hope it's visible in the video. You can look at the size difference. This is 16 cross 2, the green one, and the blue one is 20 cross 4. So you can write around um, 20 cross 4 characters. I think that constitutes to around 80 characters in total. 80 characters, so you can write in a total of 80 characters. So what I'm going to show you now is this graphics LCD. This is a graphics LCD, and you can just look at the size difference. So it's not a character LCD now, it's a graphic LCD, the same LCD which you guys have in your laptop and your phones and every and every it's it's found nowadays everywhere. um uh, oh, okay, welcome salam. So by graphics LCD, I mean an LCD which has pixels in it. So it's a black and white LCD, but still we can call it a graphics LCD because obviously we can display some really cool graphics in it. And I've also already printed. I've already printed an image in this LCD, and I've released the video on Shorts. And I did that with 8051 when I was in my bachelor's, and it was nearly 7 or 8 years ago, I think, because that was in 2018. Sir, please use the hardware that we. Okay, well, you'll get to use that, and obviously, I have been telling you to use that in lab as well. And if you're not using the hardware, then it's your fault, because everybody else is using that. And I have asked you guys to use the hardware and come to me for the if you want to program your controller, you can come to my lab. But um, uh, it's totally your fault. I've already told you what to do with your hardware. Okay, anyways, so these are the different LCDs. So all of these LCDs are essentially, these are black and white LCDs, not colorful. That's what I mean. So if you want to use a colorful LCD, then you have to go look for an RGB LCD, and I have them laying around, but it's very much messy around me, and I cannot found any LCD laying around, so it's pretty much very hard for me to look for an LCD. So what I'm gonna do is, now I'm gonna get started with the thing what I was doing earlier, and let's get back into the book. Okay, back into the book. What we have to look for now is this program, and what this program does is, this program only prints NO on line number, row number, the first row obviously, and column number fifth, which is position number 4 when getting started with from 0 to 4. And what I have to do now is, I have to copy this whole program as it is and paste it in my Keil IDE. That's what I'm going to do now. Okay. uh, I'm gonna go to next page and copy the next step. hope that's visible. Pretty hard. It's very much it's very hard to keep track of all the stuff that's going on. Let me copy the other thing as well. This thing as well. So I think I have copied everything. Let's try to compile this thing up and see if there are any mistakes. First of all, I'll hit this button, rebuild. Bismillahirrahmanirrahim. Oh, great! Zero errors and three warnings, and zero errors is what we are looking for. Okay, great. Sir, is there a 5 cross 4 or 6 or 4 keypad in Proteus library which we require and making significant error? But the problem is that we don't know how to connect the IC on board. That's that. Okay, so there is a guy who has asked me, sir. The problem is that we don't know how to connect the IC board, and this question sound as much idiotic as this guy's name is. I don't know if he's trying to gain some sympathy or gain some followers. I don't know what he's trying to do now. um First of all, his name is stupid, and second of all, what he's trying to do is stupid. I have given you everything which I have, and okay, I'll show you the connection right now over here. I'll show you the connections. I'll show you the connections. Okay, let's get into the detail. Okay, let me turn on my camera. Yeah, let me expand it as well. So now it's visible. Okay. That is a pathetic question which this guy has asked. Okay. Anyways, I'll get in the detail of how to connect your IC on board. But the thing is that I have already suggested you guys a board which is much easier to connect everything with. I'm using a breadboard, and this is going to be difficult for me, as if I'm building anything from scratch, is going to be difficult for me. But for you guys, it's going to be much easier. So I don't think I should ever respond to this question, this type of question. um Anyways, this hardware is just to for you to get some insight about how it's made operational using a breadboard. Okay. Okay. So my program was operational. My program was working fine. Now let's get back to Proteus, and let's create a circuit first of all. A simulation, which is the most important thing which we need. Okay. So now I have to search for all the parts. The first part which I am going to search is 89C51, and it's the standard microcontroller which we are going to use. And the second part is 16x2. So there are three LCDs um, coming on this, displaying on this view terminal. So you can see in this display box. Oh, it's not visible. Okay, I hope now it's visible. Just make it a little shorter. Okay, yeah, now it's visible. So one this, second this, and third this. You should ignore all of these and you should just look for this particular LCD and double click. And what we need. Okay, my mic was turned off for a while, and that's because my OBS studio was disconnected, and now I think it's we are live back again. Um, okay, so what we need now is, you know, a circuit diagram to follow. So for now, what you have to do is you have to first of all look for the connections, and everything is already mentioned in the book. You must follow the book. So first of all, what I am going to do is I am going to zoom in this into this area in this book. Let me know when it's visible. This. Okay. Well, as you can see the circuit diagram, we have to connect port 1.0 through all the the data lines. So I'm gonna do the connections. Um, Let me turn off this book, and now what I have to do is I have to turn on Proteus. Right. There we go. Yeah. Okay. Let's get back to the business. What I see is we have to place the LCD over here because it's much easier for us to connect all of the pins. And what we have to do now is I think it's better if we connect if we mirror this item on x-axis. So what we have here is all of the connections are just mirrored, which is much easier for us to work with. So let me just draw this circuit diagram first, like this. Everything is now in sequence. You don't have to worry about any loose connections or any short circuits, which you guys are, you guys make a lot of mess when you make circuit diagrams. Oh, accidentally I placed a component and I undid it using because it wasn't placed, and as soon as it's not placed, then obviously we can undo it. So we're done with the the data lines and the command lines. What we have to do now is we have to connect RS, RW, and E pin. So RS, RW, and E, and for that we have to connect P2.0 to RS. Let's do that. RS goes to P2.0. P2.0. It's a difficult job, but I'll manage to do that as well. P2 point. Let's do that. Let's do RS with 2.2, and I'll change this in code because it's much easier for me to work with. Um, I'll change everything in code. It's much easier for me to work in this pattern. So now I have everything connected, and I hope that works. Okay. Now let's get back to the program, And let's Farman Khan AOA, Farman Khan WA. Walaikum Salam. Okay. Um, we only have to modify all of the pins. So RS now is connected to which pin? Pin 2.2. Pin 2.2. Let me turn on Proteus so you can see it for yourself. Pin 2.2. Here we go. So this pin 2.2 is connected to RS now. So wherever 2.0 was written, I have to write 2.2. 2 point, and wherever 2.2 is written, I have to write 2.0. That's all what we have to do now. 2.2, 2.0, and 2.0. Okay, great. Great, great, great. We have everything working now. Okay. Pin 2.2, RS 2.1, and enable. Oh, no, 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 no. Let me confirm it first. Enable goes to 2.0. Yeah, yeah, we're right. We're right. We're good. We're good to go. We're good to go now. Okay. Well, case now what we have to do is we have to make all the connections. Since we have already, we have already uploaded the program in simulation, it will work just fine right now. Let's see if it works or not. Let me upload the program and let's see if it works. My files were in documents. They were in delete after stream and LCD. I hope it's visible. I hope it's visible. No, it's not. Oh shoot, that's already closed. Still, it's stuck. Right. Okay. So I have to select the file. Hit first of all, before running the simulation, I have to select the frequency 0592 and hit enter. Okay. Now we're good to go. Bismillahirrahmanirrahim. Yeah. So nothing pops up. What do we have to do now is we have to power it up. We have to do power connections. So for that, I've already explained to you guys what VSS, VDD, and VEE means. So essentially, VSS is source, which is the ground. Let me connect the ground first. Ground goes over here. Okay, great. And the DC pin goes over here. Let me get disconnected as well. Okay, so I hope that's visible. Yeah, that's visible, obviously. 5 volts. And okay, let me connect this to ground first and let's see what happens. Oh, something is, at least it's blinking or something like that. It's just doing its stuff. Let me see in the detail. Um let me let I have to rebuild everything. I have to rebuild everything since I changed the program. So now getting back to the Proteus. Now what when I do this, here we go. No need to connect a pot. No need to connect a pot in this case. Great, great, great. Everything works. Okay. Just wait for a while. Send it to him. Okay. Well, it works. It works at least in the simulation. So for the hardware, let's get this thing connected once and for all, because it will be very troublesome for us to make all of the connections later on, change all of the connections later on when we um, get to work with the hardware. So in this case, let's rotate everything and let's get this thing connected to our power supply, and let's move this thing over here. Let me see if I can do this. Yeah, it's still legal thing to do. And let me bring this over here. Yeah, it's still legal, pretty much legal. Yeah, so that's all we have to do in our case. These are the connections which you have to make, ladies and gentlemen. I'm gonna paste all of the program, this whole thing, in description, and you can copy that from there and get your thing going on. Do the same connection which I have. I'm gonna paste this program right away. Just give me a second. I'm going to copy this, Control C, and paste all of the you know all of the program in description right away. ASM program, ASM program, and here we go. I've already pasted it. Yeah, I've already pasted